We'll next move into a group discussion. So if you have more questions for Psyche and the other speakers.
Okay, so I don't know about you, but I've had an amazing day. I really, really enjoyed the talks, and I enjoyed talking to so many of you and the posters and everything. But this is kind of one of my most favorite parts of our conferences, is at the end, after you've sort of absorbed all this information. Hopefully you're not too tired to take this opportunity to now try to sort of think of questions maybe that go across talks, or if there was a burning question you had for a particular talk we didn't get to your question. This is your opportunity. And the other thing is that now the three speakers can also ask each other questions. And so we can have that dialogue as well. So is there someone who wants to start us off?
Why is it called the inverse U curve when most of the studies it's like an inverse V curve?
And it's not symmetrical always either.
Because it was originally the Wundt curve, which was the inverse U curve, right?
Yeah. Blame Wundt. Yeah.
Because the negative curvature shifted parabola curve doesn't really do it for me.
Yes, we have to think of another snazzy acronym. I like how groove is now plum, right? Pleasurable urge to move.
Who was that? Thomas Matthews introduced me to that.
Yes,
plum.
I guess Tom.
But I think it may have come out of the groove workshop.
Yeah, it did.
Yeah.
Plum.
So I think we have a question.
Yeah, actually, I'm here at the top, echoing. Just a general question about all this predictive coding stuff. So it strikes me that it's very linked to perception, how people come to understand the features of music. Can predictive coding tell us something about how music comes to be that way to begin with? Can it shed light on composition, creativity, not just the perception side that music exists? How do we identify its features? Can you shed light also on how music comes to be this way to begin with?
Yeah. Yeah, so I actually think it's predictive coding, I guess traditionally had been, I mean, there are different disciplinary traditions that now give rise to what we're together calling predictive coding, which is this wonderful grab bag of things. But there's Leonard Meyer, who was really a musicologist, and then there's Wolfram Schultz, who's a neuroscientist, and there's David Huron, and they came from slightly different traditions. Steph Kolsch, yes. And I mean, I actually think of predictive coding in the neuroscience literature as more tied to the sensory, right? So sort of more moment by moment predictions, which I think things like the idiom model are doing a good job of modeling. But I also think of prediction error in like, I have like weird, wild ideas about prediction error, and maybe there's something about positive prediction error that gives rise to creativity, right? So you can have a certain set of predictions that you bring to bear from being in your culture and being kind of enculturated. And then you have negative prediction errors when there are things that violate the structure, but then what are positive prediction errors? And so my view is that maybe there's something about creativity that is a positive prediction error. So that's something that I hope to look at in the next couple of years with the natural language tools that I mentioned briefly, and then also with EEG and improvisation tests.
I would just say one thing for Jonathan, and that is that there's of course we use it in music, but in this environment, but there's been a long tradition also in other fields, and of course Carl Friston has it as a general perception action or theory about perception action or active inference. But importantly, the way that Carl Friston thinks of it, there's no positive and negative, it's only prediction error. So the positive negative is of course completely fine, but it comes from from the reward prediction error tradition, where you can have a positive reward or you can have a negative reward. And sometimes they tend to overlap, but I think if you have to be as precise as Jonathan, you would try to remember to talk about this in different ways.
Yeah. I guess I would add one thing, which is if we can take the idea that we identify with a sound as something that we could make or participate meaningfully in, and then are inclined to move to it in order to complete it in some way. Sort of, I mean, like the rubber hand effect I was talking about. You identify with the thing you're perceiving. Then at least musical rhythmic structure comes from our bodies. I mean, this is nothing terribly new. It's just maybe a new way of framing it, but comes from structures that we can identify with, structures that are sounds we've made ourselves. For instance, our gait, our running gait, our walking gait, and so our inclination to move to music comes from the fact that it resembles us. So I think that's one way of looking into it.
And why would you have cultures where they mainly have 7, 8, and odd meters?
Yeah, maybe I'll follow up and sort of try to get back a little bit closer to Stephen's question. And this is sort of, well, I don't know if you're talking about ontogeny or phylogeny. So I don't know if you're talking about the evolution of music or how music developed. But my question, well, maybe more to Jonathan, but all of you sort of related is, I'm not sure that it really says why music is structured the way it is, right? So it essentially has to do with the original priors, right? So why do we, I think, Jonathan, if I understand your model, yes, it can explain 4/4 and 3/4 time, but it's really agnostic about what particular meters should be prevalent, right? Like it could do any meter, right? And so why across cultures are there certain things that are common, and is that, so what is the developmental story essentially?
Yeah, so I talked kind of carefully around that because one, I have no personal deep commitments and don't feel I know anything beyond what other people know about this. But yes, I think, the idea of priors and inference can operate very similarly, whether your priors are implicit and just based on the things that we naturally expect since we have brains formed in a certain way, and the things that we have come to expect because we've been exposed to them repeatedly. So yeah, that said, I think there's a circularity about it too. I don't think there are any cultures that have totally done away with isochrony. And I think that's just generally very pretty universal, and I think very well could be grounded in our gait, whether evolutionarily or through exposure in the womb or things like that. Whereas dancing in 7/8, I think, is a self-reinforcing tradition. Once people started moving that way, then people started being exposed to it. Then people started, hearing it as children, watching other people do it, and it became familiar. But yeah, I don't think I have any really deep insight into the development. The development is, of course, the realm for experiment, and you're doing some great things to figure out how that works.
Do you want to say something?
Yeah, just a small thing. It's very simple in a way, but just in order to interest our brains, we need to there needs to be something new. And the dopamine system wouldn't work if you only got what you knew. I mean, if you listen to tuck, 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 I mean, your brain will find different stuff to be interested in, right? So I think as a fundamental universal principle, and that can have many different expressions, cultural expressions, but as a universal principle, I think we would try to, music tries to look out for ways to to do expectations and violate them in different ways. Some cultures are more interested in rhythms, some cultures are more interested in melody, some are more interested in harmony. And the composers within each culture, like I gave the Paul the Paul Simon example the other day, where composers, they might be more or less conscious about trying to work with predictions, but they all do it. I mean, except, and even for Schoenberg, who tried to get away with them, he exactly tried to get away with it, and he formed music that was actually more random than random notes, if you can say, yeah.
So I think, oh, I thought, okay.
Hi. So in Peter Vuust's talk, he talked about the popular Danish song where the chorus is like very different. And so my question is about how the much longer term features of music, such as the differences between the verse and the chorus, or like in dance music, like the breakdown and the drop, like how those relate to groove, predictive coding, and also social bonding.
Yeah, this would not be from a mathematical point of view, but if you think about the old structuralists and the semiotics, where you have these narration. In order to have a narration, you basically want form that is predictive over a longer period of time. So like the different models for that in principle, but it was originally thought of in terms of adventure. What do you call that? Fairy tales. Sorry, fairy tales where you always have, oh, there's peace and harmony. But is she a real princess? And then you figure out how to find out whether she is a real princess. You take P. Of course, you know this is H.C. Andersen's fairy tale and so forth. And then you get out of it, and then you come back to harmony, but in a new way. And this is, if you think about a symphony, you think about the sonata form, you start by having the main theme in the tonic and the side theme in the dominant, and then you have all this explosion stuff in the middle, and then you end up with the main theme and the side theme in the tonic. So you have learned something on the way, and this is also like a prediction, but just on a longer time scale, which animals probably wouldn't be able to do, I guess.
Yeah, so then are the brain mechanisms the same for the short term and long term? Maybe Jonathan can speculate. So would you need a completely different kind of model, or do you think the same basic model would work?
I think that's two different questions. I think on the one hand, the brain mechanisms between like the beat and the subdivision versus overarching narrative structure are bound to be different. The beat in particular is something that has, dynamics on a time scale of human movement. And I imagine that the actual mechanisms are going to depend a lot on time scales, and some of those dynamics have to be self-driving. But in terms of the structure at a very abstract level, I do like to think about structure at all these different levels as a process of inferring what structure I'm currently involved in and where I am in it. And so that can be my position in a known score of music, or it could be my position in the progress towards the beat returning at the end of a big cycle of electronica. We have these structures in our heads, and we figure out where we're positioned in them and what structure is relevant right now. And I think the push and pull between those two things is a good conceptual way to think about the process at multiple different scales.
Yeah, so I will say, like from a neuroscience perspective, right, we have different brain systems that are anti-correlated over short-term and long-term. And so things like the default mode network is quite a slowly undulating set of brain areas, and that are usually anti-correlated with the areas that you might use for things like syntax and sequential processing. And yeah, so I think that's one like possible, might have some relationship with the way different musical structures unfold at different scales. The other thing I'll say is also that when we haven't mentioned attention at all, right? But sustained attention is, I mean, listening to a long piece is a sustained attention task. And I think part of that, you know, and I think the models that we've been, like that I've been reading about are mostly focused on the moment-to-moment level, but with deep learning, right? Anna Huang's work, and that gave rise to the Google Doodlebug, which lets you make longer term structure than you knew was possible before. I think the innovation there was attention, right? And so the ability to focus on one moment in time and also simultaneously look at the long past and the recent past and the long future and the recent future. So yeah, so I think a couple of points there that maybe we haven't really gotten into in terms of prediction and reward yet.
I have a question that I think this panel is uniquely suited for, I hope. Your collective talks and interests, I think, maybe can tap into something that I've wondered about. So this inverted shifted parabola, as Jonathan put it, or the inverted, otherwise
Of
known
negative
as,
curvature.
Thank you for the precision. It strikes me that we talk about it when we're talking about the relationship between musical reward and musical complexity. We conceptualize musical complexity as kind of a unified phenomena. Well, maybe we break it down at times in terms of harmonic and rhythmic complexity, but we're still thinking about entropy in some way. We're thinking along these lines. But from a modeling perspective, I think the two sides of this inverted U are a little different. To the right, we're dealing with extreme prediction error. To the extreme left, we're dealing with a failure to predict. You know, as you put it, Peter, if you just have ta, 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 I'm not going to predict anything, or I'm going to invent something entirely new. So I don't know if anyone has thoughts about that the continuum is not uniform. At the extreme ends, we have a breakdown in prediction. There is something uniform in the middle. I don't know. I'd be interested in your thoughts about that. Anyone on the panel?
Yeah. So modeling-wise, again, adopting the predictive coding framework, I think, I mean, I was very particular about the idea that, you know, we move when our participation can reduce prediction error in some way or reduce surprisal. But I think at a more general level, maybe as we think about pleasure, the idea that we need, in order to be experiencing pleasure, we need predictions that are not uniformly met. And so there are different ways to lose that condition. And you know, if there were more dimensions than just, you know, plus and minus complexity, I think we would find there's lots of different ways to lose that state. But all of them will resemble in some way either not having a structure or not having errors. So yeah, I think there's lots of different things you can change, but that condition of having an implicit structure that you're able to maintain and commit yourself to while not having that structure explain everything, I think is maybe the condition. I think.
That's right, yeah. I think he's...
A gig to get ready for, I guess you're taking a pass, okay.
Are there other questions? Oh, online. Sorry, I can't see you behind here.
Hello, David Huron sends in 2 for you. Hi, David. So he says, this is a question primarily for Psyche. Conventional poetry exhibits predictability with regard to rhyming words. So do you suppose that your anhedonics might have also difficulty enjoying rhyming poetry?
So BW actually enjoys podcasts, but I think, yeah, that would be a great question. Yeah, great question. And I mean, I think another question that we've also been wondering about, maybe we now have to do it now that we were debating whether to go ahead and do it. Like, do musical anhedonics also show a speech to song illusion? Right, that's something that's like kind of well known. We didn't talk about it at all today, but you know, the fact that those two sides of song and speech you can kind of have these situations like the Diana Deutsch's voice, right? Who can that can transform you from perception of speech to perception of song. And so do musical anhedonics not show that? So yeah, great question. I don't know that that's been done yet. And hi, David.
And his second question, and I think this is to the entire panel, it should be possible to create animated visual stimuli that exhibit variations of predictability that mimic what goes on in music. So why don't we have an abstract animated visual art that plays on the same manipulations of expectation that we find in music? Is audition somehow privileged when it comes to prediction rewards?
So that's been done actually, right? There's some group, I think it's in, is it the Peers group in London that's doing some work on that, trying to combine audio and visual together to look at complexity. Yeah, I think there's so many parameters that can change. As you noted, that there's so many ways by which you can manipulate complexity.
I have a very specific speculation, which is that the sounds that we make are indistinguishable from the sounds that other people make nearby us. Whereas images, I can see what's me and what's not me very clearly. I have very specific predictions about where my body is going to be at a particular moment in time. And so the only way to really play on that is with rubber hands, where, you know, the hand is right next to mine. I think there's a very particular way in which, since we can hear something and feel as if we're producing it or identify with it, I think we can only do that through sound. Only by sound? I'm thinking about touch. Yeah, but I think it's difficult to do that visually. And so if we go towards this idea that the desire to move to music is essentially participatory and self-other conflationary, then it's difficult to do that through the visual medium. Right. Okay. So and you're right. No, you're right. You can certainly see something and recognize it with your own motor system and see that you know, what he's doing is sort of like that thing that I do.
Yeah.
Yeah.
I would just add that I think it depends also, we think of vision often because we use static pictures so much in our experiments, but the real world, visual world is like a movie, right? It's actually dynamic. So I think there are dynamic expectations that are in the visual world that you could identify and lose yourself in and feel you're part of. Or
Yeah. I mean, yeah, I have to take back what I said, but not entirely. I think that we do identify with other people in other positions, and you know, a limiting factor on deeply identifying with them is that they're in another place, so I can't actually mistake myself for him. Whereas if I'm tapping along with something, I could really mistake what I'm listening for. I mean, in various experiments, people have shown that you can transition from playing a metronome to playing feedback to somebody's tapping without them noticing at all. So there really is this like total potential confusion about causality. But yeah, we do definitely have experiences of self-other identification through the visual medium.
And of course, there are the famous theory of mind vision, where you have, or the cartoons where you have I guess it's a triangle and a square, and they are sort of playing together, and they are annoying each other, and all this kind of stuff. which is used for, I mean, it was created by Uta and Chris Frith, used for autism, of course, and you very much feel like you're one of them when you watch it. So, I think there might be something.
There's also the fact that the auditory modality is so temporally precise. So for rhythms on quicker timescales, that seems like something that is, we prefer auditorily. But for rhythms on slower timescales, the rhythm of interaction between the triangle and the square, rhythm, arcs and things like that. Yeah, I think you can create that.
I could ask one if there's nothing. So first, thank you all for the super nice talks today. I really like, Psyche, in your talk, using the anhedonia as a fringe case to help us understand better. So a general question would be, are there other types of conditions like this that we might use in our research to better understand some of these concepts? But I have a more specific question as well, of kind of follow up. I feel like David Huron was getting at what are the bounds of the auditory motor anhedonia. And I was wondering if you looked more generally, and it could just be my own ignorance on this literature, but are there other, like your case study, does he also lack pleasure with like taste or touch, other modalities? Are there any correlations of this auditory anhedonia with other?
No. So did that last one, you asked like 5 questions in one question. This is great. So that last one, so BW definitely enjoys good food and like other things that aren't sound, right? But he did not enjoy the rustling of leaves in the trees. And so that actually went against Macerero's paper, which had shown that musical anhedonics don't have displeasure for environmental sounds. And so that prompted us to test that more specifically to see how much that was driven by extra sound associations. But the first question, other fringe cases, I mean, I think congenital amusia is a really interesting one, right? Like, so this relationship between music and language is also something that, like, curiously, we didn't talk about much today, but I think that as a way to look at language types of difficulties, like specific language impairment or dyslexia, I mean, I think that's still an ongoing literature.
I personally am fascinated by the case of stuttering and the fact that stutterers show differences in rhythm perception and differences in sensory motor synchronization. I think that's a great way to explore, and also this facilitated speech through metronome cueing and differences in the reaction to auditory feedback to your own actions. I think that understanding individual variation in those things and covariation and all of those things can really help us start to build a clear picture of what rhythm is and how it relates to speech and movement.
Yeah, actually, now that you mentioned the self-other distinction, like schizophrenia is another model. Like, folks have talked about that as a kind of people de-identifying with their own voices. That would be really interesting to look into as well.
Question.
Hello? So we've talked a lot about predictive coding and bringing things from the ear into the brain. And I was wondering how we can use what we've learned today to flip the switch when it comes to decoding and reconstruction. How can we use our predictions on what gets put in to pull out the information again from the brain?
So did you understand? Maybe let me interpret the question. So you were saying now if we start with brain data.
Yeah, pulling out what the auditory information was.
Try to use that to see what the input was?
I guess that's what some of those MVPA models are trying to do with, and so, yeah, we haven't done that much yet, but I like that work of Ben Cubitt, who's going to join my lab in about a month, this idea of hippocampal replay, right? Given that you know what people heard, can you use connectivity patterns or patterns recorded from the brain to figure out what they had heard, to decode the input information. So that's, so there's always a danger for going down the reverse inference route, but I think MVPA is kind of the most well-established tool for that.
Question?
So kind of tying back into the first question about why it's the inverted U, why not some other function? Because like with that asymmetric kind of nature at the low end, wouldn't kind of a step function work too? Where you just like slightly increase up to medium and then you sort of fall off a cliff? Wouldn't that kind of be modeled similarly?
I mean, I think as in answer to Frank's question, the key thing is just unimodality, that there's a peak. You know, the specific models we were trying to run and use to reproduce this inverted U do produce things that are not U's. But the key insight is just that you can lose your model or you can lose the errors. And that doesn't necessarily look the same on both sides, but both of them lead to a lack of pleasure in movement.
Me. Hi.
Okay.
Oh, are you done?
Oh, sorry, one more
Okay,
question.
I'll try to make it quick. So I'm interested in this idea of how we report our perception. So Jonathan, your model, the comparison is like the feedback you get from and I know the model's primarily focused on synchronization behavior. Sorry, there's an echo and it's messing with my brain. But what I'm getting at is the difference between expressing our perception explicitly and experiencing it implicitly. So if the task is to express the beat or synchronize with the rhythm, that could be an inherently different process the brain is doing than if you realize something is violating your expectation and however you're representing it in your mind, and then like adjusting precision and things to update your prediction without the external input. So I'm curious how your model would account for that, or if you feel like it's the same as synchronization behavior.
Yeah, I mean, so what originally led to extending this into movement was, my first thought was like, okay, yeah, you estimate the phase of the beat, and then you're going to tap whenever that crosses 0. Done. And then I saw a couple of experiments like this Rep 2002, where actually really what turned my mind was this simple online experiment that I did that I haven't published or anything, where you try to do you perturb the metronome phase, which would evoke a phase shift in somebody tapping. But then instead of having them tap along, you just ask whether the next beat is early or late, and you shift that around. And that turned out to echo a number of other experiments that had been done back in the late 90s. But you see that people will make an almost complete adjustment for the phase shift and judge everything completely relative to that, which is in contrast to in tapping, where you just make this partial phase shift. And so it was clear that there's something different. And one of the possible differences is the sluggishness of your body, which has to keep up. But another, and I think maybe the more exciting difference, is that whenever you're participating, you're creating your own input. Whenever you're participating, you're doing something to your observations. And so that can involve in training yourself. It can involve, however those self-generated things affect me. And so I think whenever you're participating, you're always going to need to be taking that into account.
But of course, also you probably know that. But some of the measures we're doing when we, for instance, do predictive coding, I mean, the most studies on predictive coding has been done with P-attentive measures like the mismatch negativity and so forth. And it's only until recently in my own group that we have been starting to do stuff which is above that also, like the ones that I showed the other day, where we did the DCM on recognition of melodies, where it's actually a conscious task that you do. So I think to bridge these two things, I'm not sure you can talk about it in the same way, but it's an important thing to understand that there are both things going under the hood and in full daylight, you can say. So from the methodological point of view of the brain scanning techniques.
Lucas? Oh, yes, time. Yeah, okay, last question to Lucas.
So a lot of so just taking the very, very simple case of the model being used to predict, the next beat, for instance, in any generic predictive coding model, how big can the input of the model be? So does it matter if you know what's producing the sound? I think you all may have touched on this a little bit, but for instance, if you know that what the sound you're hearing is generated by a computer and it's regular, or if it's generated by another person that might be unpredictable, do you expand the model? And in that case, what are you modeling exactly? Does that?
Not quite clear on.
Okay, not clear.
Yes. You restate?
So, does it matter if you know that it's a computer generating the sound, or if it's something else that might be off, like another person?
Right, yeah, I think he's asking what other information you would put into your prediction.
Yeah, how big does the input to the model get? Yeah.
I think I understand. If you know something, if you've been listening to a very steady metronome, that context can then inform the precision of your predictions. If you've been listening to something that is somewhat irregular, you're probably going to have a weaker prediction. There's this paper coming out very soon by Florencia Aseneo, I don't know how to pronounce her name, and Keith Doling that looks at the ways in which irregular rhythms can lead to predictions, but they lead to predictions in different ways. People have, so thinking about like the fact that we'll have more precise predictions that are context dependent. And then there's also the fact that the specific sounds that we predict, we may have more or less precise predictions about, depending on the form of those sounds and whether they have sharp onsets or not. There's a version of this model that I've never put together. There's always more things we're keeping track of in the world that are informing our inferences about the world. And so there's a million different pieces that you can plug in and add on. But one thing that we are keeping track of is how precisely we expect that next sound to happen, and what type of sound it is. And so that you could feed in some measure of it would basically be volatility. It would be a dynamic measure of how precise I'm expecting things to be based on context. That's not in it right now. I think this model as a framework is useful because it can start to umbrella all of these ideas as they come up and are shown to influence behavior.
Yeah, and I would also say, of course, there's these studies with the virtual partner that you're also doing here, right? But I would just like to interest you in an older paper by Chris Frith and colleagues, where they had this stone, scissors, rock, paper, scissors, rock. Is that how it is? Yeah. Rock, paper, scissors, yeah, sorry. It's above my bedtime, So, but just where this was a wonderful study where they were playing with somebody in the scanner, and they were playing this game, and in one condition they were playing with the computer, and in another they were playing they were told that they were playing with a person, and you would see different activations, but in fact they were playing with the computer all the time. So just, and you should, it's a very good paper. It's very, very interesting, and that could inform this question in a way. So, yeah.
Okay, well, I'd just like to thank the speakers one more time for coming. Yes, so this was our 19th NeuroMusic conference. So next year is our 20th. So I hope you'll all be back. And not only that, but next year is the 10th anniversary of the creation of the LIVELab, the opening of the LIVELab. So we hope to have lots of celebrations next fall 2024. So you can already put that in your calendar. So we may have an expanded conference for a couple days instead of one day. And I think the number of people here, number of posters and everything probably indicates people would like to have another day of interaction. So thanks again. I hope most of you can make the concert tonight. And if not, I'll see you around, or at the very least next year. Okay.
Yeah, just not to steal a moment, but just say a little bit about the concert. You're going to be hearing a young guy from New York, Tommaso Perazzo, I think his name is. He's originally Italian, and I've just met him today. We haven't played before. He is somebody you're going to be listening to in a short while. He's just fantastic. So,
As is the rest of the trio.
Thank you.